Okay, here's problem 5 from homework 3 of NCS 350 in fall 2012. Problem 5, I'll show you the solution. Consider NRZ and NRZI line coding schemes. This is non-return to zero and non-return to zero inverted. Use graph paper or spreadsheet to draw the waveform for each case described below. Part A says use NRZ on this bit sequence. Part B says use NRZI on the same bit sequence as A. And on the NRZI, you have to know that the signal level for the first bit is a 0. And as I review the scheme for NRZI, you'll see why we have to give you that. Here's the solution, and you can see that I've said NRZ, NRZI line coding. For part A, NRZ, I've copied the bits down, and I also gave myself a little reminder here. What is NRZ? NRZ is the simplest of them all. 0 volts for a 0, 1 volt of 1 for a 1, or whatever it is, 5 volts, 3.3 volts, whatever. 0 for a 0 and a 1 for a 1. Basically 1, 1, 1, 0, 0, 1, 0, 0, 0. Okay, following this pattern. Okay, and so this is properly labeled voltage, let's say. For NRZI, I've also given a little reminder here. We're going to change on a 0 and we're going to stay on a 1. So whatever voltage we're at, we're going to switch it if we get a 0. And if we get a 1, we're going to stay on the voltage we're at. And that's why we had to know and had to be given that the level of the signal on the first bit is a 0. So if I label this as a 0 and that is a 1, then on the first bit I have 0 and I stay. When I get a 1, I stay again with a 1, I switch on a 0, switch on a 0, stay on a 1, stay on a 1, switch on a 0, switch, 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 stay, switch, and then stay. Okay, so you can see how I got this, I hope, and I hope that helps with problem 5.